All that you have just learned about storage is really in the background. Your virtual machines actually don't even know about the underlying storage devices. Your virtual machines believe they are using traditional SCSI hard disks, which is why they can be moved from storage device to storage device without interruption. In vSphere, the virtual machines are stored in containers called data stores. These are just logical volumes that allow you to organize the storage of your ESXi host in virtual machines. Think of a data store as a drive where you can store virtual machine files and ISO images. You can even browse the data stores to upload and download files within the vSphere web client. Although the virtual machines don't see the difference, there are two different types of data store: VMFS and NFS. The VMFS data stores are built on local, iSCSI, Fiber Channel, or FCOE storage, whereas the NFS data stores are built from connections to network-attached storage, or NAS devices. Both types of data stores support shared storage and all the vCenter features we discussed earlier. And now, as you can see, even storage uses networking. So let's explore virtual networking. We mentioned earlier in this course that virtual machines take advantage of virtual networking. It turns out that so do your ESXi hosts in vCenter. As you just learned in the storage section, your ESXi host can leverage storage technologies such as NFS, iSCSI, and FCOE, all of which rely on traditional Ethernet networking. In addition, your ESXi hosts are managed by the vCenter server and leverage the network for features such as vMotion, HA, and DRS. And finally, your virtual machines use the network to communicate with each other and the physical world. All of these things require something known as virtual networking, so let's explore what that means. Virtual networking is really very similar to physical networking. Each virtual machine and ESXi host on the network has an address and a virtual network card. Those virtual network cards are connected to virtual Ethernet switches. The only thing we're missing are the virtual cables. Why do we have to use virtual networking? Think about the rules of physical networking. Every device must have its own network card and address. If you had 20 or 30 virtual machines on your ESXi host, that would be a lot of network cards. In fact, you would have a challenge fitting that many network cards into a server today. Instead, VMware took a different approach. We know how to make hardware into software. That's what virtualization is all about. So why not create a virtual Ethernet switch in software? That's exactly what we did. Now let's see what these virtual switches can do. As we've said, VMware took the programming and logic of a physical Ethernet switch and turned it into a virtual device. It's very similar to how a virtual machine is built out of virtual motherboards, network cards, and storage controllers. It's just software that behaves like hardware. The rules of networking are still enforced. Virtual machines must have the proper addresses and protocols, but it can be done with a lot less cable mess. You can use these virtual switches to attach your virtual machines to the physical network, or you can create isolated networks to be used during testing and development. With virtual networking, you have the same flexibility that server virtualization provides. There are different types of virtual switches, and you can choose the one that best suits your business needs. Just like physical switches, virtual switches come in different forms, each with a different feature set. vSphere supports two main categories of virtual switch: the standard switch and the distributed switch. Both switches help you to reduce network clutter by reducing the number of physical network cables plugged into your ESXi hosts. Each ESXi host comes pre-built with a standard switch that provides basic connectivity and management features. The distributed switch expands upon that model by providing a central interface to manage the different connections and features found in the virtual switches. As a result, the distributed switch is able to provide more features as a result of this centralized management approach. Let's briefly talk about some of the features found in virtual switches. Virtual networking can be as simple or as complex as you need it to be. Here are some of the features supported by vSphere. VLANs provide logical separation of your network traffic and are often used to isolate different subnetworks, such as a test or a restore network. Traffic shaping is a feature that allows you to restrict the inbound and outbound network bandwidth of a group of virtual machines. This can help reduce congestion in your virtual network. Port mirroring gives you the ability to monitor a virtual machine's traffic for troubleshooting or intrusion prevention. It allows you to capture all the traffic sent to or from a virtual machine for later inspection. Quality of service, or QoS, and DSCP are networking standards that allow network switches to prioritize certain network traffic over others. For example, you may wish to prioritize the voice traffic from a call manager server to improve performance. NetFlow is a network monitoring tool that allows you to determine your top talkers on the network, as well as other metadata about the communications that occur on your network. CDP and LLDP are discovery protocols used to identify neighboring physical network switches. They can be used to help discover and help troubleshoot misconfigurations. Now that we've discussed the storage and networking aspects of virtualization, let's take a step back to see where all this fits into our discussion so far.